right. Instead of a live class connect this week, I'm making this recording because I will be out of the office on Tuesday. So either watch the class connect session through a class connect session or watch the video, either way. We will not have a task for today. I'll eliminate that Dropbox, but here's some help with some of this material. I know a couple of you especially have been struggling with probability, so I'll start from the very beginning. Okay, reviewing simple probability. It's just a ratio of numbers saying what is the number of favorable outcomes, things that we want to have happen, over the total number of outcomes. The most common one is a dice. What's the probability of rolling a 1? There's only one number that we want. What is the total numbers that we could roll? There are 6 different numbers. Probability of rolling a 1 is 1 in 6. Now, for simple events, we just need to count the outcome. I gave the example of rolling a die. There are 6 possible outcomes. If we're flipping a coin, there's 2 outcomes, a heads or a tail. For a deck of cards, there are 52 outcomes because there's 52 different cards. Now, not all probability is a simple, straightforward like rolling a die or flipping a spinner. Sometimes there are multiple events, and to be able to calculate the probability of those is a little tricky. So there's something called the fundamental counting principle to help us figure out how many possible outcomes there are. Remember back here, calculating how many outcomes on a die or in a deck of cards was really easy. But this fundamental counting principle will tell us how to calculate that bottom number, how many different possible combinations there are, even if the situation is really complicated. So for this example right here, you're at a football game with some kind of a concession stand where you can get sandwiches with either wheat or rye. For a meat, you can get salami, turkey, or ham, and as a side, you can get chips, a brownie, or fruit. How many different possible lunches are there? This isn't so easy as counting how many numbers there are on a dice or how many numbers there are on a spinner. You can do this by creating a tree diagram, noting which option, and which option, and for each option, calculating the different combinations with the option preceding. So if you have a wheat and a rye, you've kind of separated it there. All of the ones up here are going to have wheat bread. All the ones down here are going to have rye. Now, once you've done that, you can have salami, turkey, or ham. All of the options up here are going to have salami. All of the ones down here are going to have ham, and then having the option of the side go with it. You can see this gets really complicated really quickly. And so mathematicians discovered that what you can do is apply a fundamental counting principle. By taking the options available for each stage of that tree and multiplying them by each other, you can come up with the total number of outcomes. Now with the sandwich example, it is possible. We could manage this tree diagram, but it can quickly get out of hand, and being able to apply this and multiply the options together becomes really handy. For example, in this situation, we have 8 different students, and you want to line them up for a picture. Now you can see the thing with the sandwiches, there were only 3 different things that we are worried about in different orders. Now we have 8. I don't have enough room on this board to do a tree diagram to function and calculate this. Lucky for us, we have the fundamental counting principle. So let's apply that to calculate how many different options there are. Here's a slide just kind of explaining what I just said. So if we have 8 slots, 3, 4, 5, 6, 7, 8. How many choices would we have for the first slot? There are 8 different people. How many choices could we put in the second slot? You might be tempted to put 8, but that isn't necessarily true because one person has already been decided here in the first slot. So really, there's only 7 different possibilities for that second slot. And once that second slot is filled, there are really only 6 slots for the, 6 possibilities for the third slot. 2 people are already chosen. They're decided. You can't take them out of slot 1 and put them into slot 2. So if we fill in the rest of these numbers and then apply the fundamental counting principle by saying, okay, there are 8 options for this first slot, 7 options for the sixth slot, the 7th slot, 6 options for the 6th slot. Phew, I'm talking and getting confused in my words. It's the same thing as when we had the sandwiches. There were 2 kinds of bread, 3 kinds of meat, 3 kinds of side dishes. We're going to multiply them. Only you can see these numbers are going to get bigger, and exactly why there was no way I could possibly do this on a page. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and if you plug that all into your calculator, you get 40,320 possible combinations for 8 students to stand in a line. Huge. And that is so much easier than creating a tree diagram. Okay? Now, mathematicians didn't stop there when I told you they wanted to do things simple and easy. Instead of writing out 8 times 7 times 6 times 5 times 4 times 3 each time, they developed a shorthand. And that is an exclamation mark. Exclamation mark means this. Multiply that first number ahead of the exclamation mark by every consecutive number lower than it until you get to 1. So instead of writing out 8 times 7 times 6 times 5 times 4 times 1, they just wrote 8 exclamation mark, which is 8 factorial. When you see the word factorial, what it means is 8 times every number lower than it. So what is, this isn't me being excited about 5. That means factorial. 5 factorial is 5 times 4 times 3 times 2 times 1. And if you want to chug that into your calculator and figure it out, it equals 120. Now, what about division? What if you see something like that? Remember what factorial means really? It means 4 times 3 times 2 times 1 divided by 3 times 2 times 1. Now, you can multiply everything out on the top, which gives you 60, and you can multiply everything out on the bottom, which gives you 6, or you can apply the principles of canceling that we know already. 1 divided by 1 is 1, 2 divided by 2 is 1, 3 divided by 3 is 1, and we're left with 4. 4 factorial divided by 3 factorial is 4. Okay, mental timeout while we're processing this principle about factorial, and then we're going to go back to probability and apply it. Okay, so far we've been just doing one event, but sometimes we can have compound events, 2 events, and we want to know what the probability of both of them happening. What if we are rolling a die and tossing a coin? What if we are spinning a spinner and drawing a card? What is the probability of getting some specific event for both of them? So, there are 2 different kinds of compound events. One of them is called an independent event. If you were doing one thing, what happens there does not affect what happens in the other event. For example, if we are rolling a dice and we are flicking a spinner. If we flick that spinner, is what happens on that spinner going to affect what number we roll on the dice? No. These are independent. And when we have independent events, we multiply the probability of the two events together to calculate the total probability. Okay, here it is in a Venn diagram. Basically, here's what could happen in one event, and this is what we want. Here's what could happen in another event, and there's what we want. The probability of both A and B where they overlap. That would be found by multiplying the probability of both. So, how it's written. Basically, a P for probability of rolling an even number. What's the probability of rolling an even number? Well, there are 6 possible outcomes because there's 6 numbers. How many even numbers are there? 2, 4, and 6. Those are 3 different even numbers. And again, let's simplify. 3/6 is the same thing as 1/2. All right. The second event, spinning this spinner over here and landing on an odd number. Well, how many numbers are there? There's 8 different numbers. 1, 2, 3, 4, 5, 6, 7, 8. How many odd numbers are there? 1, 3, 5, 7. There are 4 odd numbers. And again, let's simplify. 4 over 8 is the same thing as 1/2. So the probability of rolling an even number is 1/2, and the probability of spinning an odd number is 1/2. To find out the probability of rolling an even number and spinning an odd number, we multiply them together. 1/2 times 1/2 is equal to 1/4. Or a 25% chance of being able to have both of those items occur. There's math is done nice and even if you wanted that. Let's look at another one. What is the probability of selecting a jack? Well, there are 52 possible cards we could draw. Of those, only 4 of them are jacks. That simplifies to 1 in 13. What's the probability of flipping a coin and getting a tails? There's only 1 tails we want, but there's 2 possibilities. 1 over 2. Oh, no, this is... Did I do that right? I'm guessing instead of chunking the math. That should be. Okay. We get a 1 in 26 chance. 1 divided by 13 times 1 divided by 2 gives us 1 over 26. We want that percentage. Comes out to 0.038 or a 3.8% chance. Which rounds to 4. All right, I'm going to stop it here and I will continue with dependent events in the next video.